All right, 7.6 dilations. You've pretty much already been doing dilations. We're just giving it all new terminology, new notes here. So we're going to write these in our notebook. So follow along. Today we're going to cover what it is, identifying types of dilations, finding the scale factor, dilations and similar figures, and coordinate plane. Okay, so if you need to pause, go ahead and pause. You need to have these written down in your notes. You need to know a dilation is a similarity transformation. Think when we are transforming something, think of what you know that means. We are changing it, right? Change. So dilation is just changing a shape from one thing to another. We've already been looking at them this way, so this isn't going to be very different. So we have our original figure. That's the one that we're getting and starting with, and then the image, that's the new one after we make changes to it. So really, if you think about the activity that we did, you had the original on the right side of your screen, and then when you moved the triangle around, or you scaled it bigger or smaller or rotated it, that would have been your image. So we have special ways of naming these. Let's go with a triangle since we've been doing a lot of triangle work lately. I'm going to draw a triangle, and I'm going to name it A, B, C. So that's my original triangle. Now an image, let's make it bigger. So same exact shape, just bigger. We would call this a prime, which just looks like a dash. So let me write that over here. Pronounced A prime. That's just what we call images with the points. So A prime, B prime, and C prime. So whenever you see just A, B, and C, that's the original. When you say A prime, B prime, C prime, that's the image, the new triangle. So let's look here. So I have an original triangle. We're going to actually look at what we've been talking about in class, scale factor, dilations, whatever. So I'm going to go over here and do it because I can't do it in there. We're going to actually copy this triangle and paste it in again. So this is the same exact triangle again, right? The same exact triangle twice. So those would be congruent. Now, if we make it bigger here, that's the same exact triangle. We just blew it up, right? We also can take that same exact triangle and we can make it way smaller. But we have to keep all the sides the same proportion, right? That's what we've been talking about. Those ratios have to be equal. If my smaller triangle looks like this, that's clearly not the same triangle anymore, right? We have to give all the sides the same factor. So if we want to double it, we could double it. If we want to cut it in half, we can cut it in half. But it has to look exactly the same as the original triangle. So going back to our notes here, that changed one, or if we flip it upside down or do anything else to it, that would be our image. So next we're going to talk about reductions and enlargements. A reduction, make sure you have these in your notes. Reduction makes it smaller, and an enlargement makes it bigger. So if we have our original triangle over here, A, B, C, we can make that way bigger or way smaller. So I guess I should draw a bigger one since I'm doing reduction first, right? Let's make it nice and big. And we don't only have to look at triangles. Let's look at a rectangle. So this one would be A, B, C, D. Name it however you want. Now I can take that same rectangle and make it smaller. And remember, the image, we give it the prime, little dashes. A prime, B prime, C prime, D prime. You can see my original shape is A, B, C, D. A prime, B prime, C prime, D prime is clearly a lot smaller. So that means it's a reduction. So questions will ask you, is this an enlargement or reduction? Make sure you pay attention to which one is the original and which one is the image. A lot of times you'll also see the center of the dilation point. What that means is when we draw a line extending, oop, that was a bad one. Let me draw on the line first. If we draw in a line, let me get my ruler out here, from B to B prime. I'll do it in another color so you can see it. B to B prime, like that. It's going to go all the way out here. We could do the same thing with A to A prime. So let's connect those. We could do the same thing with D and D prime. Oh, I should have drawn those lines a little longer. And C prime. So a lot of times when you're looking at dilations, they'll look like this. And if you draw them all long enough over here, let me extend these ones a little bit. They all have a point where they'll meet. That is the center of the dilation. We'll label that in the next one too. You can label that in your notes. Center of dilation. And we'll actually look at, there's proportions here from A to A prime, and then from A prime to the center. We'll look at those, but a lot of times you'll see those lines drawn in to actually explore the dilation, but really you're just looking at these shapes, so don't let those confuse you. So an enlargement is the other way. Now if I draw, we'll do a triangle now. I'm going to draw A, B, C, and now I'm going to draw A prime, B prime, C prime. Remember, I can flip it upside down, I can do a bunch of stuff to it, but clearly my original one is smaller and then I got bigger. So don't always read these left to right. See, I put my original on the right this time. Make sure you look, A, B, C is the original. When they have these prime marks, that's your image. Original image. All right. So let's go ahead on then. Next, we're going to try these. I'm going to go through the first one with you, and then you're going to do the second one in your notes. We are going to do notes checks, so make sure you are trying this. If you don't understand it, make sure you circle it so you know to ask me for help, okay? So looking at number one, I'm just going to find my original first. I see PRQ. You see it? We find PRQ. We've got our original triangle. Now I see P prime, R prime, Q prime. So I'm going to give these some color so I can see them better because all these lines are a little bit confusing. So if you're a color person, now we can see them, right? So from our original, this one's the original. Did we get bigger or smaller for our image? Clearly this one looks bigger to me. So I'm going to say that this one is an enlargement. Now you go ahead and do the second one. You can pause the video to do that. All right, the next thing that you can do is find the scale factor, which is just setting up our ratios and dividing. We already know that scale factor is how big or small we're making it. And remember, it's not adding to all the sides, it's multiplying all the sides. Like doubling a recipe, we're multiplying everything by 2, right? Or if we double our pay, we multiply it all by 2. Or if we cut our pay in half, we're dividing it all by a half, right? Or multiplying it all by a half. So these ones we're going to tell reduction or enlargement again, and then we're going to find the scale factor. Remember, scale factor is a factor and can be found by dividing. So this says decide whether it's a reduction or enlargement and find the scale factor. So first looking at this one, I see this one says P, and this one over here says P prime. So we see our original and our new one. Then I see we have some numbers in here. We have 6 and 2. And remember, this C is the center of the dilation. So we can look at proportions and ratios of those dilations. Instead of doing our ratios of the sides, let's set up these ratios of the numbers we have here, the distances from the center. It's how far away is this P point from the center and how far away is this P point from the center. right? So I see if we're going from P, the original P over here, our original shape, to P prime, I'm going to start with P6 over P prime 2. So your scale factor there is a nice whole number. It's 3. Remember, don't be afraid of fractions. So again, I want you to do the same thing for this one. You should do your original distance over your image distance from your old one to your new one, okay? All right. We can also use those same proportions to find x. So I'm going to find my shapes first so I can see them. We've got this. Here's my shape. And then here's my other one. So I'm seeing some sides labeled here, and we also have the distances from the center. Remember, we know how to do ratios with both of those. I see this top side corresponds or is the same spot as this over here, QR and Q prime R prime. So I'm going to write that as x over 6 equals, now let's use our ratios. So we're going from the big shape to the small shape, right? That's how we wrote the first fraction, so that's how we have to write the second fraction. So P is all the way over here, and P prime's here. So P is 14 away from the center, and P prime is 8 away from the center. If you're not seeing where those came from, we're talking this. There you go. And then you guys should know how to cross multiply. If you are still struggling with cross multiplying, make sure you ask me in class for help. Checkpoint 2, solve for x. So I just did 1. I want you to do these 2. So go ahead and pause the video and work through these 2 problems. Circle them if you're not sure how to do them. All right, last thing we're doing in our notes today is on a coordinate plane. There's this trick to remember, but it's basically what you already know here. It says x comma y, the coordinate. That's the original right here. The image is kx comma ky, but k is the scale factor. Really, it's just remember, we're multiplying it all by something, making it bigger or smaller, sorry. So draw the dilation Imogen, that's Imogen, it just means image, with scale factor of 1/2. So factor of 1/2, it means we are finding all these points that we have on our graph, and we're changing them by a factor of 1/2. It means we're cutting this whole shape, we're making it half the size it used to be. So I'm gonna write down my coordinates first. Remember, we go across the x and then across the y. So 1, 2, 3, 4, 1, 2. So this one is 4, comma 2. But what am I forgetting there? I went 4 to the left, so -4, and then up 2. Then this one is 4, 2. We have 4, -2, and -4, -2. If you're confused on where those numbers come from, make sure you ask me. Now, changing it by 1/2 means I need to change all those points by 1/2. So if we're looking at -4, 2, multiplying by 1/2 on both of those. So -4 times 1/2 and 2 times 1/2. Let me draw it in colors. There we go. You also can think of it as dividing by 2. So then our image, -4 divided by 2 is -2, and 2 divided by 2 is 1. So we get all of our new points. I'm going to erase all these points. They're in my way now. But we're going to find all these new points. So again, original image. And we'll plot all these new points. So that new spot is over -2, up 1. Oh, let's change the color here. When we find